This is the second problem. It is amphitherism. You know the amphiphilic or amphibian? You know what is amphibian? It's I don't know. You guys remember one of the cartoons? There's a turtle is. I'm an amphibian, not a reptile. There's a over the hedge cartoon. Anyway, amphibian or amphitheater means both, right? You have the both natures, and that's an amphi. And an amphi means both sides. And then the protic means, I guess, something that proton donors or proton acceptors. So it means what is an amphi protic nature is, it could be an acidic or it could be base. Right? So we'll just say acidic. They can serve acid or base. And this first question is bicarbonate ion. What in the world is this? Right? Bicarbonate ion is, you need to know how to write the chemical structures. Chemical structure of carbonate ion. Do you know what's the structure of carbonate ion? What you commonly have in your soda drinks? CO3, 2 minus. That's a carbonate ion. Okay? When you have a lot of CO2, they make this carbonate ion. What is a bicarbonate ion? HCO3. What is the charge for this then? You essentially have a 1 plus, you make bicarbonate ion, right? This is a baking soda. Sodium bicarbonate is a baking soda. It is just a minus charge. So that's a bicarbonate ion. And the way that you write is an amphiprotic. Okay, I want to show how this one is when HCO3 minus is base. And this is a case that, okay, HCO3 minus dissolve in water. If it is a base, they're going to receive an H plus, became H2CO3 and OH minus. So in this case, this is a base, right? And that's how you do it. And then this is a carbonic acid. And this carbonic acid is, can you guys see that this can decompose into H2O and CO2, right? So this is actually happening when you dissolve the CO2 in your soda. They make this carbonic acid. The carbonic acid is actually decomposed into the bicarbonate or even the sodium carbonate, and so that they can make a different compounds. So this is a case where it's a base. What about HCO3? Now I want to see that this one is happening as an acid. Same scenario. In that case, you're going to lose this one. So because of that, HCO3, 2 minus. And somebody, I guess, has to develop, has to receive it, and the water is receiving this. So this is the final one. And this is where bicarbonate can behave as an acid, when the one before they can behave as a base. Do you know what's the other most common amphiprotic chemical compound molecule? What is one of the most famous one? H2O, H3O plus, OH minus. Water is amphiprotic, right? If you look at the water here, the water on the left-hand side receive a proton, so this is behave as a base, whereas this one, I guess, a donate or lose a proton. So this one is lost, the H plus, became OH minus, so this is an acid. So water itself can be an acid or a base. So they are also amphi.